Welcome to Spring LIB.
In this question, we have a uniform chord of length L and mass m that is hanging vertically. And we want to show that the speed of transverse wave of this chord is square root of gh. What is h? H is a variable. So for any certain point, h is a distance from the bottom. So when we get this expression, we should immediately realize that the speed of traveling, the speed of the wave will not be the same at the top and at the bottom, because at the bottom h equals 0 and at the top h equals L. So how do we find the speed? We have this equation that V equals the tension divided by mu. So tension, for example, so let's first find mu. Mu is mass density of it, which is m over L. What is tension? At any point of the chord, the tension of it is caused by the gravity of the segment of string that is below it, because it's this amount of string that's pulling onto this point. And the mass of this amount of string is m over L times h, because mass density is m over L and we have h amount of string. So this is a mass of all the segment of string that is below a certain point, and we time it by g to get the gravity or the tension in the chord. And then we simplify this equation to get square root of hg. Part B, we want to know how long it takes for a pulse to travel from one end to the other. And this is where we need to use calculus, because we can see that as the wave travels, its speed changes. The speed is 0 at the very bottom. The speed is square root of GL at the very top. So let's write down the differential equation. dh, the change of distance, equals velocity times time. And velocity is square root of hg dt. So we can rearrange it to have dt equals dh over square root hg. And we take the interval of both sides to get t equals 2 times h over g. And technically plus a constant, but we start from t equals 0 when h equals 0, so the constant is just 0. And this is an integral from 0 to L, so that is 2 times L over g. So that is the time it will take to travel from one end to the other.